And this is the quick review of systems with three equations. So general principle. If you have two different variables, you need two equations with those two variables. If you have three different variables, you'll need three equations with three variables. If you had four different variables, you need four equations, etc. 4 and above, you're usually going to solve using a matrix. Okay, this is 3. My first decision is, do I want to get rid of the x's? Do I want to get rid of the y's, or do I want to get rid of the z's? And I'll do that by elimination, just like the elimination method with two equations with two variables. So I'm going to look at the variables. I have a positive 3x, a positive x, and a positive 2x. Not bad, but let's see how the other ones are. Because remember, you have to get them to be equal and opposite to add out. Positive 2x and negative, or positive 2y and negative 2y, perfect. Those are ready to add. What's my third one? Positive 4y. That could work with the middle one. Yeah, I like the y's. They look good. But let's check, make sure the z's aren't even better. Positive 1z, positive 2z, positive 3z. They're not bad, but they're nowhere near as good as the y's. So what's our decision? Let's get rid of the y's. So again, I'm looking. I've got to make, listen now, two groups of two equations. That's what I need. Two groups of two equations. So if I take the blue one and move it over to the black, perfect. There's now a group of two equations. I'm going to use the black one. I'm going to use the blue one. And guess what? These are going to be ready to add, right? Remember, we're looking to get rid of our y's and see how the y's are equal and opposite. So these are all set to add up. Okay, but I have to make a second set, and I have to decide that. Now I've got to use the green equation. So I'm going to go ahead and put this green equation over here with the blue. Now I've used all the equations. I have two sets of two, right? So again, I just use this, right? It's over there. And again, one of them gets used twice. That's what you have to do if there's three of them. And we have our two sets of two equations. Okay, left set is ready to add up. I get 4x plus 3z equals 5. This second set is not ready yet. I need to manipulate it. I've got to multiply this top equation by a positive 2. Because again, remember, I'm looking at my y's, right? And I need them to be equal and opposite. So if I multiply it by 2. Okay, so for clarity's sake, let me write the new blue equation. 2x minus 4y, perfect, plus 4z. And don't forget that 2 has to go to both sides, and so you get an 8. All right, so now it's these two that I'm adding up, right? Okay, so when I add them, 4x, 0, great, plus 7z equals 17. Notice now I have two equations with the same two variables. If you don't have them at this point, you've made a mistake, and don't make that mistake. Okay, so now it's just like a normal system. I've got to add these two up. Okay, well, if you look, they're in great shape. I'm going to rewrite just for clarity's sake so you can see where we're at right now. So there's the first one. Here's the second one. And I can solve by substitution or elimination. But as you can see, this is nice and handy to eliminate. How about if I distribute this negative? That'll be negative 4, that'll be negative, and that'll be a negative 5. And watch what happens when I add these up. The x's add out. I get 4z equals 12. Move the 4. Z equals 3. Perfect. I've got z. Now, again, I go back to one of the two equations that have x and z. I can choose either one, and I'll be able to get x. Let's use the one on the left. The numbers are a little smaller, right? So now I got 4x plus 3 times z equals 5, right? And we sub in our 3. So I get 4x plus 9 equals 5. Add a negative 9 to both sides. That's a negative 4, and x equals negative 1. Perfect. We've got two of the three values. What's left? I've got to get y. I've got to choose one of these equations to end up getting y. I can use any of the equations. And again, I'm looking at y. Here it's a positive 2y. That seems easy for me. So 3, sub in the x value, plus 2y plus sub in the z value equals 1. What was the z? Z was 3. What do we find for x? Negative 1, right? See how I subbed in those values? So I get negative, here, let's stay black, negative 3 plus 2y plus 3 equals 1. 2y equals 1. And guess what? Y equals a half. Final answer. X first, negative 1. Y second, half. And z third, 3. Negative 1, half, 3. Negative 1, half, 3. What was this? Consistent and independent. Guess what? All three lines intersect at the coordinates negative 1, half, and 3. Hey, that's the idea. Systems with three equations.